You can win all day long on the facts, even if everything you say is right. There is a segment of the people in this country particularly, and in this world, that we need to get on board. We're not going to get them on board with fear. We're not going to get them on board with facts. We have to touch some other part of it.
So exactly, what do I do?
That's what I'm saying. I think you have to diversify your message into a broader thing that's sort of unassailable, because you are literally shouting against a mountain every day. If you can draw from a deeper well of sources that go back thousands of years. Go read or bring in somebody who's an expert in people who have a deeper understanding, that bring in the historical and spiritual perspective. I mean, maybe once a week it could be a special feature.
Hi there, my name is Debar Thomas. Welcome to the first installment of Resistance and Renaissance. We believe that we need a Renaissance to run parallel with a resistance in order to increase freedom throughout the world. Our first installment will be talking with Samuel Lewis Dell, author of The Einstein Illusion. In The Einstein Illusion, Mr. Dell actually argues that all of modern physics has been in the dark for over 100 years. He defines space and light and time and gravity and the magnetic fields in ways that you will finally understand without feeling intimidated. Enjoy the interview. After the interview, we will be talking about how to build a virtual republic to run parallel with our Renaissance and to work in tandem with the resistance. Quite profound itself. Mr. Dell is on board for that. We look forward to talking with you and having your replies. Thank you. This is Samuel Lewis Dell. We are here to interview him on his book that he has published called The Einstein Illusion, which has a subtitle down here which is quite interesting, called The Infirmity of Modern Physics. And we are going to ask some key questions to Mr. Dell. Welcome. Thank you for taking some time.
I'm glad to be here.
And just to kind of open it up, what got you going to write a book like this?
Because I just had a lot of questions. I wanted answers. I wanted to understand. I expected, like a lot of other people, that relativity would give us some real answers. Well, in digging into it, it had more questions than answers, and so I ended up writing the book.
Well, let's start with some of those questions. What's the first question that kind of surfaced for you?
Well, it kind of goes back to how we think. Mathematics and measurement, for example, we think those as being objective, but in reality, measurement, for example, is related to the object. So if the object has relativity and changes, then the measurement changes. So measurement in mathematics is relative to the objects that they study. And this is the problem. And so you go back to Michael Faraday, and he studied the electromagnetic relationship between the electric field and the magnetic field. Well, in his measurements and his analysis, he treated these two fields as particles. So everything he did was related to particles. Well, Maxwell comes along and he says, okay, I will put your experiments into mathematical form. But Maxwell said there is no particles. And so he has an equation that measures something physical, but the physicalness does not exist.
Because he got rid of the particle.
Yeah, he just says the particles don't exist. It's just a force that just seems to come out of nowhere like magic. And so that's where we have been since Maxwell's electromagnetic equations. And that's where everything is built upon those equations. It's like you run a mathematical relation, but you don't know what is moving. You don't know what it is. You have no physical model.
So what you're saying is before we even get to Einstein, there's Faraday who came up with this concept of a particle, and that was completely done away with.
Yeah, basically in tradition. In other words, he says they're just magnetic particles and they're electrical particles. He didn't really try to say what the size was or what the shape, but he says, well, something is moving. And Einstein took the equations, Maxwell's equations, and he came up with the special theory of relativity. And tradition kind of pushed the idea of physicalness out the window and adopted some sort of magic of things just happening, forces coming out of nowhere, out of emptiness, appearing and disappearing. And for thousands of years, you go back to the sophists, debating between Plato and you go to the sophists, they wanted the physical world. And Plato comes along and says, no, it's a subjective world. And so we've been fighting these two worlds for a long time in philosophy, and you have objectivists and you have subjectivists. But the problem is the science goes back and forth, and they don't realize that mathematics and measurement, the real scientific process, is really neither subjective or objective. It's relative to the object. So if the object changes, the measurement changes. And that's what they don't understand.
So what you're saying is they base everything on observation.
Right. And see, observation by itself is not objective. And this is where science has made the mistake, because you observe something 1 minute, it's one way, and the next minute it's different. So it's relative. Observation is relative to the time of measurement, the way you measure it, the way you see it, and the way you observe it. That means objects change. So your observation changes. So observation is relative.
So you're basically challenging the scientific method as we currently accept it.
It's observation is not objective. It's relative.
Okay.
And we have to understand that. And that's where Einstein's special theory of relativity is based on observation. So observation is relative, therefore we understand it. But when you try to equate observation to objectivity, meaning that this object moves and changes, then you've got a problem. The observation can change, but not the object. Now, if the object changes, there is a reason. And that's the next problem that physics fails to do. Why does it change? We put things out into the heat and they expand. In the cold, they contract. But we don't explain that in terms of physics. What is the cause of things changing? Take Einstein's photoelectric effect. He understood that photons were particles of some sort. Some physicists going back, it's corpuscles, photons, particles, you could come up all kinds of things, but it's something physical that gives a push against something. And they're bigger particles and they're smaller particles. They're red particles and they're blue particles.
Right.
There's something that is causing that push. And Maxwell says, no, it's a wave between electric and magnetic fields.
Something between the two.
Yeah, it's just like an oscillation between two fields, which is fine. But where does the idea of field come? We're talking about the meaning of field. Throughout all classical history, a field of what?
There was something that was in the field that was the field
you
itself.
have to say what is in the field that is causing the field to move. When we look on the waves of water, we're talking about water molecules.
Right.
They move up and down, oscillate. Air molecules. You know, they knew waves, but they didn't know what the particles were in water until later. They could actually see the molecules moving. And so when you're talking about an electric wave or a magnetic wave, it's naturally to assume there's something that's doing the waving.
Right.
And if you do not accept this, then you go into a whole world of magic that a force comes out of nothing. You know, and it's like a bowling ball going down the alley, and you don't see the bowling ball, and all of a sudden the pins knock over. Well, what caused them? You want to know what caused those pins to fall.
So because the elimination of the particle was done away with, we don't know what that wave is comprised of.
Right. And so this is where the special relativity came in, the saying, well, because there is no particles and there is no substance of what we can grab our mind onto and figure out, therefore things just happen strangely. That's what really relativity has come to be, and that's where the problem is.
So can you explain where Einstein went wrong along this historical path? What was his assumption?
Well, it was really based on the Michael and Morley experiment. And it was based upon the constant velocity of light. And his classical statement, E equals mc squared. Very simple equation. The c squared stands for constant velocity of light. Here we're talking about measurement. And yet they take the constant velocity as an absolute. It is not an absolute. Light bends around corners. Light changes its direction. When it glances past the sun, it curves. It has all different variables. It comes in different sizes, perhaps different shapes. We just don't really know the intricacies. We just know there's a division. It's called quantum. In other words, there's different sizes. So if there's different sizes, logically that presumes that there is different numbers of units. And so it's quantized in the fact of particles, at least in concept. We don't know what these look like, but there's got to be some kind of a particle. Well, when they don't put the particle nature to it, and they say light has an absolute velocity that never changes, there is a contradiction, there is a paradox. It doesn't work. Not with the mind. The mind doesn't accept that, because the mind has the ability to say what is doing the force, what is causing the action.
So E equals mc squared is energy equals mass times the velocity of light, which is constant, squared.
Right.
That's basically what that means. And the assumption is that the constancy of the velocity of light is a constant throughout all of the universe.
And it's not.
But they based that assumption on observation, right? Which
Right.
was the beginning of the fallacy that has, lasted for over 100 years now.
When you go through the early experiments on the velocity of light, they felt that originally they believed there was an ether. Okay?
Some mysterious thing out there.
Mysterious substance, that light was a wave in the medium. And so, but their mistake was to assume that the ether was rigid.
Okay.
See, and so when they do an experiment and they realize the motion of the Earth against a distant star going, one time the year is going one direction and another time it's going the other direction, then they think, well, we'll study this in these two directions, and there's absolutely no difference between the velocity of light one time of the year going one way towards a star and another time of the year going away from the star. There's no difference in the velocity of light. And so what they do is that they say there's no ether. Well, that they conclude this based upon the assumption that the ether was rigid. And it had no relation, that it's like filled the whole universe like a rigid stuff that was just sitting there, and planets were moving in this rigid ether. But
so where did they test this speed of light? Wasn't it in a vacuum tube?
Yes.
On planet Earth?
Yeah, you had to do it in a vacuum on the surface of the Earth.
So they didn't test it for on the moon or on the sun?
Well, they would find that no matter where you tested it, logic would say the same results would happen. But the thing is they weren't testing the velocity of light by measuring when it started and when it ended. It was a refraction method. But they were only concerned about, did it change in velocity? Not to know exactly what the velocity was, but there was no change in velocity, which made sense. And if you did the experiment on the surface of the sun or the moon, it would be the same, because you're talking about there is no change in velocity of light. And so they assume that it has a constant velocity. But the problem is, if light bends around corners, and we know for a fact that when it enters a pane of glass, it goes slower, and then when it leaves the pane of glass, it picks up. And so they assume that in a vacuum, if the vacuum was on the surface of the Earth or on the surface of the sun, the same velocity would pass through this vacuum, the very same. Wrong.
It's wrong because, why? Explain this. Because the vacuum, they say that the vacuum, there's nothing in a vacuum is defined as zero atmospheric pressure.
Yeah,
so they say there's nothing in the vacuum.
It's zero matter.
Zero matter.
But not zero magnetic field. If you take the magnetic field in that vacuum that's passing through, the Earth's magnetic field that's passing through, it's going to be less than if it's on the surface of the sun and the sun's magnetic field passing through that vacuum. And you go on the surface of the moon, it's even less magnetic field passing through. So there is going to be a difference. The magnetic field is going to change from the surface of the sun, surface to the Earth, or surface to the moon. And so until you can eliminate the magnetic field, you can't really determine the variation of light. You don't know if the magnetic field has an effect on the light.
And in reading your book, I was realizing that the magnetic field, as you describe it, it's very much like the ocean. You go down deeper and there's a greater degree of pressure on physical matter. And it's the same thing with your magnetic field. It's a graduating magnetic field in density, meaning at higher altitudes it's less dense, and lower altitudes it's more dense. Can you explain that?
Well, atomic clocks is a very perfect example. An atomic clock is based upon similar concepts as carbon-14 dating. It's really measuring the motion of light. And so when the motion of light vibrates through space, you can actually time the sequence, and so you can say light travels a certain velocity. But if you take the clock on the surface of the Earth, it has a certain time compared to atomic clock sitting on a laboratory somewhere, and then you go on top of Mount Everest and you compare, the clock goes faster. Why? Well, relativity, space and time changes. Well, that doesn't answer the question. Why can't the magnetic field affect the speed of that clock? And if the magnetic field affects the speed of the atomic clock, which is nothing more than the measurement of light, then light goes slower the closer you are to the Earth than you are at a high elevation.
So you're saying there's a difference between the standard of measurement and the unit of measurement, time and the timepiece.
Right, there's a difference.
And they've merged the two as meaning the same thing.
Yeah, when they start talking, well, time changes, well, time is relative. But the problem is the clock is relative more so in a way that, because if it's hot, it ticks faster, and if it's in a more dense field, they refer to it as a gravitational field. And so a dense gravitational field, then it moves slower. And a weak gravitational field, the clock moves faster. Well, what is a gravitational field? They don't know. But we do know that there is a magnetic field. So why not just say it is the magnetic density that causes the speed of time?
Can you explain a little bit about what this magnetic field is? Before we go back into light, can you explain what this magnetic field is?
We just go back to Faraday. He assumed they were particles. So we don't know. It could be any kind of a particle. But the magnetic field is something. It turns a magnetic needle. It does things. It causes electric currents to move. So something's doing the force. And so if we just say it's a certain monopole of some type, shape, form, you can do anything, but it's something that's doing the forcing, something that's doing the cause. Okay. Well, if you have something there, then that means there's a relative density of that something. So you have to say in certain cases that it is more dense. So if you have around the North Pole, the magnetic north, not the physical pole, but the magnetic north and the magnetic south, you go to this area, theoretically, the magnetic field would be more dense in the poles than it would be in outer space. So why don't they take an atomic clock, take it to a magnetic north, and let it sit there and measure the time, and I can guarantee you it will go slower than it will at the equator.
Because the magnetic field is denser in that area.
Right. And that's the same thing in gravity. The higher the elevation, the faster the clock goes. The lower the elevation, the slower the clock goes. So you just have to say it's not gravity, but it's the magnetic field. And this is what physicists are just oblivious to.
So Einstein was stuck with that assumption.
The constant velocity of light.
And because of that assumption, it threw the entire field of physics into a science of mysticism, which is what you describe in your book.
Right, that's correct. And Einstein was just following the traditions. He was following the assumptions of the constant velocity of light, and therefore when Michelson and Morley measured and they said there was no change in the velocity, they assumed that to be true. But the reason is that the light comes down to the surface of the Earth, and as it gets closer to the Earth, it slows down, and when it passes through the vacuum of the experiment, it goes at a constant velocity relative to the density of the magnetic field on the surface of the Earth. So it does slow down and it speeds up. It just depends on what the density, magnetic density is in space. So light would travel faster in outer space than it does on the surface of the Earth.
So basically, we really don't know how fast light can travel.
Right. They're just using a constant velocity is based upon a measurement on the surface of the Earth, and they don't know. So all their calculations are fallacious.
So this is interesting. If you go back to in history, we had the struggle with, is the world round or flat? Okay?
Right.
Well, we've based the speed of light on our planet, only our planet, and we haven't factored in other planets in the galaxy, how fast light might travel on their surface, let alone just in the space between.
Yeah, it's just that they're just stuck with this constant c square as the basis, and it should be E equals mv square. V meaning a variable velocity. And if they did that, everything would fit into the universe. But c squared, it doesn't work. Only in an isolated incident on the surface of the Earth where the measurements are taken.
So would it be v squared or just v?
V squared, because the square is only a torque of an angle. The square is just like a radial curvature. You're measuring the same thing of a angular velocity. The square determines the angular velocity.
Okay.
And so E equals mc squared is nothing more than the angular velocity of light going around and around in one spot. And like if you take a ball at the end of a string, you know, and you spring it around, but the minute you cut the string, it flies off. And well, that's the same principle as light. Once the light is in the electron at a high angular velocity, and the minute it fires a photon, the electron loses mass, and the photon takes off into space until it goes for centuries maybe, until some electron somewhere or some particle of mass absorbs that photon and makes that mass bigger. That tells you right there that light and mass are interchangeable. However, they say mass and energy is interchangeable. That's incorrect. Light and mass are interchangeable, but not energy and mass. Because energy is the motion of mass. E equals mc squared. You take out the mass out of the equation, the energy is zero. You need mass to get energy.
Right.
So if there's zero energy or zero mass, you have nothing. So you have to have both mass with energy.
Okay.
So light is mass in linear form. So what mass left the electron is traveling in space as a particle.
Okay. But it's traveling through this medium we call the magnetic field, or your graduating magnetic
Right, and
magnetic
it's
field.
because the light, it's not a particle. It cannot be a particle because the equations say that you have the magnetic field and you have the electric field, that they run at right angles to each other.
You gave an example of light spiraling around. Your model of light is basically a spiral helix
Right.
Can you explain how that works? And it can't even exist without a magnetic field. It needs a magnetic field to
it
exist.
doesn't move. It needs magnetic space to travel in. If you take away magnetic space, light won't move. It needs the magnetic space, but the magnetic space becomes like a linear patio stones that the frog jumps on. The patio stones represent or an analog of the magnetic field, and the frog is the analog of the electric field. It goes from one particle to the next. But because Faraday says it's a right angle relationship, then all you do is spiral the electric field around the magnetic field at rest. Now, I mean not perfectly at rest,
Right.
because that depends on you as an individual. If you're moving, it's going to be different. This is what Einstein tried to illustrate in his classical relativity. He says things change based upon where you're positioning, where you're moving, and that's classical relativity. And he used classical relativity to prove his special theory. But he made the mistake of assuming the constant velocity of light, and it's not constant. Gravity proves it. Light is changing no matter where you go. It changes color, size, direction, speed, everything.
There's two things I want to cover that really help understand this whole arena. Is first, why has science moved into this realm of changing the meaning of terms based upon their observation and not what you call a predicate method of thinking?
Well, space, for example, you have to understand that they treat space as something objective. Science treats everything objective. Mathematics objective, time objective, space objective, everything is objective, like something physical. Space warps, it's physical. Well, if space is not physical, but is a capacity of the mind to apprehend space in the mind, here is a space, here is an empty box. Space is something that's rigid, it's fixed in the mind, it has a very rigid definition. And the minute you put it in the objective, what is warping? That's like saying emptiness warps. Well, you got to have something that warps. You just can't have nothing warping.
So basically the classical definition of faith or space is empty expanse, and now they want to warp empty expanse.
Yeah, I want to warp emptiness.
To keep the magic going. So they have to keep the magic going in some way.
This is really an element of magic. Here you have the modern physicist. It's his new religion. He wants magic just as much as the religious fanatic. And he will believe anything you tell him because the equations say so. He justifies his theory by some equation. But the equation says we need something physical to measure to make the equation work. But they deny the physical. That sounds like a religious person. They deny the physical. Well, the scientist denies the physical to make the equation work. And that's the same problem. They do the same thing that people have done through thousands of years. They get magic embedded into their thinking.
Okay. So we've gone 100 years in this kind of darkness because they talk about time dilation and singularities and black holes, and they confuse the red shift and the blue shift, and they want to warp space. It's almost like a science for confusion. But what's interesting is whenever you talk with a lot of academics in the field of physics, they love to confuse you because it gives them a sense of prestige and power because they know something you don't, but they can't explain what they know. Am I right in assuming that?
Well, you go to a religious fanatic, it's the same problem. They sit there, preachers, you'll be saved by grace, all you have to do is believe, it's the whole world of magic. And you have you can't counteract that. You feel intimidated because you can't really counteract it.
They've got a sense of authority about them, and you call it an authoritative assumption.
Yeah, that's basically it.
Because they have that sense of authority, they then say something which is really based upon an assumption.
Yeah, but it's based upon mathematics, assuming that the mathematics is objective. And it's not. It's relative to the object.
Which you are now observing.
And so the object changes, so the mathematics changes.
Okay.
And they won't believe. This is where that transition that the mathematician cannot make. What am I measuring? Is electron volt, for example. Well, electron volt on the surface of the Earth might behave differently than in outer space. You just don't know the speed, its variation, whatever it is. So if the object changes, the measurement's going to change, and the math is going to change. So mathematics, observation, and measurement are all relative, just as the objects are relative. Mm-hmm. The only thing that's not relative is the mind ability to define something. And this is where Plato was basically correct. Mm-hmm. The subjective world was more precise than the objective world. But he didn't understand the predicate aspects of relativity. And so between the subjective, which is fixed and rigid, and then you have the predicate, which was relative, and the object is something that you can touch and feel and understand and put together, is different. And this relationship to all three of these realities, but philosophy only gave us two, subjective and objective. And they put all of the predicate realities in the objective. That's what science did.
They just shoved them in the same side as the objective.
Yeah, but yet when you study relativity, there's these subjectivists that are trying to pull relativity into the subjective. And they're trying to pull observation into the subjective, as if I think something, then it will be. It's almost like the religious person. I believe it and it'll happen.
Well, they're imagining things like fourth, fifth, and seventh dimensions of reality. And you're saying that there are three realities. What's the difference?
Just that there's three realities, just like there's three dimensions. Mm-hmm. And you cannot, the mind cannot conceive for it. And so when someone says there's a fourth dimension because the mathematics say so, you here again, you say, what is the mathematics measuring? And it's the same thing that You take velocity. There's the first derivative, the second derivative, and the third derivative. You could add as many derivatives as you can. It doesn't make any difference, but that is not a dimension. That is the change upon a change. Something is acceleration. It goes faster and faster and faster, and it keeps picking up speed. And that's one derivative after another. But a dimension is this, by the mind. It's a 90-degree angle. And that's how the mind conceives space. And when you say that there's another dimension, 190 degrees from another, the mind can't do it. Mathematics can, but they don't use the 90 degrees. It's a derivative. It's a different principle than a 90 degrees. It's the difference between geometry and c square. You know, c square always 3 cubed. It doesn't matter how many. You could have c 24, but that's not dimension. We think that the square is the dimension.
But it's not.
But it's not. Now, in the c square, it is, because it is at right angles. And we go to 3 cube, it's a third right angle. But when you go to 4, there's not another right angle. There isn't one.
So if you were to go see a 3D movie and it's in, you see a first dimension, two-dimensional, and then finally three-dimensional, you really can't imagine anything outside of a 3 dimensions.
You can't.
It's incomprehensible. Yet they want to intimidate you with the fact that they think that there is a 4th and 5th and 7th dimension and all these things, but really it's a different frequency of light, is what you're probably assuming.
Well, I don't know whether it's I just say things vary in velocity, and they're changeable. All things are changeable and they're variable. But that doesn't mean that there is a 4th dimension. That means that we look at it incorrectly. And so if you have a rigid philosophy and you have a I say religious because that's basically what it is, a rigid or religious idea of the constant velocity of light, you're stuck in this hole. And to explain things, you have to come up with a special theory of relativity. But if light does not travel at a constant velocity, then everything is smoothed out and everything makes sense.
So what I'm seeing here is the consequences of this thinking is it would actually affect everything from carbon-14 dating to our understanding of radio waves, in fact. We are basing a lot of our knowledge on a lot of stuff that really is in fallacy or in darkness, basically, is what you're saying.
Yeah, carbon-14 is the same thing as, works on the same principle as an atomic clock. And that's the velocity of light in a short distance. Where is that clock? Is it moving? Is it a high elevation, low elevation? It is near a highly magnetic flux density, or is it a very weak magnetic flux density? So you're going to have all kinds of variations. And they did an experiment of atomic clocks on high altitude planes going east and west direction. And you can read these in relativity books. And you can, but the problem is that the clocks going west versus the clocks going east, they have a completely different velocity. The time changes. You know, we can understand the plane being high, that the clocks will go faster. They understand that. The higher elevation, the clocks go faster than if they are on a lower elevation. But they can't explain the east and west. And the reason is because the jet airline that's going west is following the sun, which means that you have the Earth and you have the sun, and the magnetic density within here remains constant. So as the plane goes, it's staying with the sun. Okay? And that means the magnetic field is basically at rest relative to the two planets. But when it goes east, it's like going into a wind of magnetic wind, and that means it's going to slow the clock down.
It's going to have a physical effect on the mechanical instrument measuring time.
Well, it's not a mechanical instrument.
Electronics.
It's a photo instrument. You're measuring the velocity of light.
Okay.
And so what's happened is the light slows down because the magnetic field is more dense, and therefore the clock slows down. But they will not look at it realistically. And no matter how many physicists I presented this to, they just did not want to answer my question. I mean, one of the greatest relativity writers, I should say, was talking about a black hole, where something is falling into the black hole and it becomes elongated, you know. And then he was saying, and just previous to that, that the special relativity says that as the high velocities, they become shortened. So I walked up to him in class and I says, well, what happens if it's going through a black hole at the close to the speed of light, and in the high speed, it wants to shrink it, and the black hole wants to extend it. What's it going to do? He couldn't answer me, because I have to go through complex relativity equations. He would just sloughed it off. And I remember reading a book when they discussed the velocity of the atomic clocks as they traveled east or west direct. They used the same argument. There must be some complex relativity equations which would explain this difference. And I say it's simple. The magnetic field is different.
But why does the mind, so-called great scientific minds, choose a path of indeterminism, a path of magic, a path of confusion? Why does the mind want to choose that path?
Same reason the religious fanatics. It's just now we have equations to justify our belief. The Christian or that has a magic of I'm saved by all I have to do is think I'm believed, you know, that's fine. Well, the physicist, he has his magic too, but he justifies it by equation. And everybody justifies their magic in different ways. You have political people who want things controlled because they want them in a controlled fashion because things are so relative. But if I can control them, I can fix them and I can make them right. And so they have a problem because nature doesn't do that.
They say this will save you or this will protect the poor. They'll justify by these other means.
Everybody has a form of magic to solve their problems. Mm-hmm. And every human being is stuck with this dilemma of avoiding responsibility to the physical universe. You have to obey certain laws of conservation if you want to survive in it. There is no magic, but yet they want to defy everything so that they can say there is magic. They won't say it's magic, but that's exactly what it is. Warp space, warp time, no matter what, black holes, everything. But everything can be explained by a relative magnetic density and the velocity of light.
That's making the things change. That's affecting the movement of light and everything.
Right, it's affecting their conclusions. And students go into physics and think that it's their new religion. It is a new religion to these people. It's a modern religion. It has the same psychological needs and fills the same needs as everything else, and that's what our problem is in our education.
In summing things up, there's one thing you make mention of to kind of wrap things up. This has been very stimulating, and I'm sure it's going to get a lot of people debating. You're actually challenging a lot of people's magic, and you're taking that away from them, and they're going to cry bloody murder. I can just sense it coming right now. But you make an interesting. You bring up an interesting concept of a control particle being what intelligence is. You don't have any really evidence on this, but you kind of speculate. This is the only area that you speculate in the book as to what intelligence is.
Well, we're brought up believing in a physical world of what we see and what we observe. If we can't observe it, it doesn't exist. And evolution teaches us the same principle, that intelligence is not part of the equation. It's just a chain reaction of 1, 2, 3, and going down a linear path. And Michael Faraday felt that the electric field was a particle, and he felt that the magnetic field was a particle of some sorts, and they reacted to each other. Well, we know that things come in threes very easily, 3 dimensions. We can have 3 basic types of particles in the universe without any problem. You could have, imagine that the electric field spirals around a magnetic field at rest, maybe counterclockwise or clockwise. It remains to be seen. But then maybe, and there's another field that travels in the opposite direction. You don't know. And so it's possible that you could have a field that is just like light, and you could form whole different universes that are actually superimposed on us, and we can't see them. Because it's, you know, there's a fascination of the dual universes. Everybody wants to pass to another universe and the other. But the point is no one can come up with an explanation of what the other universe is made of. And so if you have another field which we can't touch, we can't see, we can't measure.
Like a magnetic field, but it's another field.
Well,
you can't see or touch.
A magnetic field is really the intermediate field that both fields work on.
Okay.
So in other words, light needs a magnetic field to spiral through space, or matter to exist. In other words, without the magnetic field rotating through the particles, you know, they could not exist. Well, if you imagine a particle that is of a control field, but it's also using the magnetic field, you couldn't see it because there's no electric properties. We only can measure electric properties. We can't measure magnetic properties. So it's possible, but I'm not saying it is. I'm just saying it gives better perspective so people don't have to look at the physical world of evolution as being
the only
cause and effect.
Right.
But their other universe, an intelligent universe, has an effect on this universe.
Which is anti-entropic.
Right.
The physical world is decaying and it's always going downhill, but
Right.
the anti-entropic universe is progressing and moving forward.
Yeah, as intelligence always grows and develops from a lower degree to a higher degree, but this universe that we live in goes from a higher level to a lower level. Naturally, it goes downhill.
But the mind, the thinking mind, can actually grab a hold of the physical world and go downhill with it.
I guess you could say that. And that's our problem in our society, is that we want to, our intelligence goes downhill with the matter that we possess, and we deal with it. And we can't seem to see through that dilemma. It's like he who has eyes to see will see, and he who can't is just going to fall. So people become, in a way, kind of a stupor of thought and confusion. They're blind because they can't see. And this is basically not only physics, but politics especially, and religion. It's so full of all of this magic and all of this strangeness that now we can't see clearly. And if we want to change the world we live in, we have got to learn how to look through this and see the responsibility that we must maintain to order to understand things rather than just accept the magic. And when somebody comes up to me and talks about curved space, I challenge them, and pretty soon they walk away from me because they can't answer my questions.
Because you confront too much responsibility.
Yeah, because you have to be responsible to say what is moving. And if something is moving, That means I have to be responsible to that. That means there's a law and function, and therefore I have to obey that function, and therefore I have to live with a certain sense of responsibility. But this was the problem that Christianity had for so long. And a modern Christian said, I just believe and I am saved. And you can't get that out of their head. And that's the greatest darkness on the face of the earth, that there is no responsibility for the individual to face as he makes his steps in life. If I get up in the morning, my body has to regenerate, I have to have exercise, I have to have nutrition, I have a responsibility to do. I raise a family and there's children, there's responsibility. And everybody wants to escape responsibility. I mean, you can watch the typical TV series today and everything is no responsibility. You're all smart and you're all intelligent, but there is no responsibility.
So you're saying that a Renaissance would be responsibility reborn.
Right. That is the #1 element. And can you imagine a God trying to teach us this? And we don't get it? And do you think that if he came down and had a flashing lightning and says, do as I tell you, that we would see this?
Oh, he can't force that. We have to figure that ourselves.
If we can't see, we can't see. So he has to wait for us, and we have to learn. And this is the problem. I mean, the atheist, for example, has no responsibility at all. He wants to alleviate the responsibility, but then he says, well, they're still good. And so how does he bring about good? Force.
Right.
He wants to legislate force and wants to make it right, make it fair, make it equal, because there's no faith in the way he does things. Responsibility says, I have to have faith in other people. I have to trust other people. I have to allow other people to go their way and learn their way. And I have to teach and be patient, and I have to be long-suffering, just like a good parent is to a child. And if we don't do this, we're going in the wrong direction. And this is really the change that has to be made, is responsibility to the universe we live in.
Well, we appreciate you taking this time to talk with us. We'd love to come back and talk again on your second book you're ready to publish, which I believe is called The Platonic Idiom.
Well, that's one, but
we'd like to come back. Can we come back to talk about that another time?
Yeah.
And we understand that you are writing another book, a third book, that you dare not speak at this moment.
Yeah, it will be coming out.
Okay. Well, we'd love to come back again to visit with you. Thank you for this opportunity to get some clarity on the subject of physics and how the entire world of physics has been in the dark for over 100 years.
Well, I hope I helped.
Oh, we appreciate it. Thank you.
Okay.
Thank you for listening to the first installment of Resistance and Renaissance. We believe that Renaissance is important in these days. I'd like to talk for just a second about a virtual republic. Remember at the very beginning of the interview, we were talking and listening to Billy Corgan, and he brought up that word unassailable. We need something that's unassailable, something that cannot be co-opted by more darkness. We believe a virtual republic is that answer. Imagine a virtual republic where all those that are part of the Renaissance, all those that are awake, who hunger after more freedom, all get involved in a virtual republic. And we are pushing to the forefront some of the best ideas, the best thinkers that are out there, that are wakening us up to the darkness that we've been in for the past 100 years, just like the interview you just witnessed. If interested, email us now or go to SocraticRepublic.com. SocraticRepublic.com. We've already started some of the technology involved. If you're a technologist, maybe with some Ruby on Rails back-end experience with a lot of web programming, we'd love to hear from you. We need your help. We've already made partnerships with some online services where we can embed this technology in a lot of different platforms. Let us know. We'd love to hear from you. I look forward to our next installment of Resistance and Renaissance. Thank you.